Hello fellow Scratchers. Collectible coins, awesome jump through platforms and per level spawn points. I'm Griffpatch and welcome back to our series creating a tile scrolling platformer in Scratch. Wow, are we at part 7 already? But there's so many other exciting game features yet to cover. We've got some really good content today though, all centering around the concept of non-solid tiles. Let me show you why this is so important. If we quickly lay down some coins here on my level, then, as you are probably more than aware of, we can currently jump up and stand on top of them. Why is this? Well, it's because every tile in our level is treated as fully solid. Well, except of course for the background tile costume too. Now, if I run over here to the right, I have these blue tiles. These are supposed to be semi-solid platforms that I can not only run and jump through, but, here's the fun part, they are still solid to stand on. But for starters, let's get Mario collecting coins. So, digging into our scripts, hold on folks, something's different. Oh my gosh, look at these cute Scratch blocks. Oh man, what is going on? And you can tweak their ears! Oh yes, I happened to record this episode during the Scratch April Fool's Day update of course. I'm so sorry if you don't see these beauties on your project. The event only lasts for a few days a year. So, we'll start by making a new list named Tile Shape for all sprites. This will work a bit like the tile keymap list we made for the editor sprite. We'll be adding one row for each costume in our tile list. We'll click then into the tile sprite so that we can see our tile costumes and their numbers. I'm going to invent a code to represent the shape and solidness of a tile. These first two costumes are easy. They are empty tiles. So I'll simply leave the first two rows empty. For costume 3, this is a fully solid tile, so I will use the hash symbol to represent it. I can see that costume 4 to 8 are equally solid, so those two can be hashes. And scrolling down the costumes, I can see 9 and 10 are also solid. Now here we are getting a bit more interesting. These first blue platform tiles are completely non-solid. So I'll enter no value into rows 11 through 16. But scrolling down further, I can see costumes 17, 18 and 19 are the top costumes for the blue platforms. These are only solid when being walked upon, so I'll represent them with an equal symbol. And then costumes 20 to 23 are again solid blocks, so put in a hash for these. The final 4 costumes are coins, and these are again to be non-solid. So I'll make sure they are empty rows in the tile shape list. Excellent, that's all set up. Let's make it do something. Click into the Mario sprite and the code tab. We'll need a new variable, name it tile shape for this sprite only. Find our define key tile at XY block. This is where we get all the information about a tile at a given point on the level. At the end of the script, the variable tile will be set to the tile costume that was found at X and Y. We'll add to this the shape of the tile, so set tile shape. To item tile of tile shape. Next, find define fix point collision at XY. Here is where we are using the get tile at XY block. We'll split off the scripts below and add in an if tile shape equals the empty tile. That is, we've touched a completely non-solid tile. Then we stop this script. This makes the following check for a tile being greater than 2 completely redundant now, so let's get rid of that. The rest of the scripts can be brought back in under the new if. Let's give this a quick test. Okay, good. The floor is solid. I can walk on it. And nice, I am able to walk through the coins. That's a great improvement. Hold on a sec. Some of you may find your Mario sprite is sitting behind the coins at this point. If so, then come out of full screen mode and simply drag the Mario sprite with your mouse. And when you release it, it will be restored to the front once more. Now come over to the blue platforms. So great, I can already walk in front of the platforms, but as of yet, we can't jump up through them. The top rows are solid tiles though, which is a start. But we're getting ahead of ourselves now. Let's go back and revisit these coins and make them collectible. Scroll in the scripts to the define check around player block. This script is used to check what's going on around a player. At present, it is just looking for us falling off the screen. We'll add in a check for collectibles. So let's get tile at XY, and then check if tile equals... Now, which costume was the coin? 24. So if we are touching a coin, 24, then we'll replace item tile index of tile grid with 2. That will replace the coin with an empty tile. We can give this a test. Now this is promising. The bottom coins are collected, but our reach is not quite high enough to get those upper coins. Now check that pressing the green flag causes the coins to all reappear. You see, it was important to wait until we had added level saving and loading before collecting coins. Had we collected a coin before saving the level, the coin would have been permanently deleted when collected and would not have returned. Okay, let's extend Mario's reach to include the coins above 2. Make a new custom block named check around player at X : with an input of X, a label of Y : and another input of Y. We can now substitute this new block for the getTileXY and its following if check. Move the X and Y variables into the new block, and then plug in the X and Y input variables from the define block into the getTileXY. Now we can change the Y variable to be Y minus 8 to check just below Mario's center, and duplicate the whole check block and change the minus 8 for a plus 8 to also check above center too. To be honest, you may consider changing these values to be quite a bit bigger, like plus and minus 16. Anyhow, let's give it a quick test. Yep, that solves that, but like I say, you may want to experiment with slightly larger values so that you can collect things higher and lower down. How about we add a quick coin counter to keep track of how many coins we've collected? Make a new variable, coins, for all sprites. Then we'll change coins by 1 after removing the coin from the level. If you want to add a sound, then this would be the place to do it. All we need to do now is set coins to 0 at the beginning of the define game loop to ensure the count is reset when the level first begins. Giving this a test, and that works great. The coin count shows how many coins we've collected. Now for something much more exciting, these jump through platforms. Here's Mario jumping up through a platform. He never collides with these while travelling upwards. But when he falls back down, his feet cannot pass down through the top of a platform tile. We can detect this type of collision by starting with the variable mod_y. That gives us the distance from the bottom of the tile to the collision point. And then subtract fix_dy, which tells us the distance Mario last moved to get to where they are now. If the combined value is above the tile bounds, then we must have moved down across the line to get to where we are now, and a collision should occur. So, first we are going to edit the fix collision at point block, adding a new label of part : meaning which part of Mario's body we are checking, and an input also named part. For the two usages of the fix collision at point blocks, where we are checking for y minus height, enter the word feet as the part. Now scroll down into the define fix collisions at point block itself. We need to move the set solid to 10, below the set mod x and y blocks. Bring in an if before we set solid to 10, and check whether the tile's shape equals an equal symbol. That is, whether we've collided with a jump through platform. Now, we know in here that we're colliding with a platform at this point, but we only want it to be solid when we are passing down through the top of it. Start by adding another if, and add an or block. Then, not part equals feet. This will be true for any collision that is not our feet, allowing us to quickly rule out non-feet collisions. Now we also check for mod_y subtract fix_dy is less than 32. If this case is true, then we did not pass through the top of the platform either. So we stop this script, which means that any collision that was our feet and originated from above the tile will count as a collision. So I can't wait to run this project and give this a go. Legging it now over to the blue platforms, and jumping up, I pass straight through the platform and land solidly on the top. Wonderful. And now I'm just testing that I can land on each platform, and also jump within a platform without any strange collisions. No, I'm really happy about this. It is working great. Now, many platformers give you the ability to drop back down through a platform by holding the down key. In my observations, this may not be a general Mario dynamic, but I will still show you how to do this, in case you want it in your game. All we need to do is add another if, checking whether down of controls is greater than 0. That is, the down key is pressed. Then stop this script. So, no platform collisions are reported when the down key is pressed. Too simple, right? Let's just test that little tweak. I can still jump onto the platforms, and pressing the down key, woohoo, straight down through the platform. That's really fun. Okay, our last task for this episode is to invent a way to define a spawn point for each level. That is, the position where our player will appear when the level begins. To start with, we need a way of placing the spawn point from within the level editor. For this to be possible, we need to add a Mario costume to the tile costumes, so that it becomes placeable. I'll just drag the first Mario costume into the tile sprite like this. Now, moving into the tile sprite, here is its costume number 28. We'll have to remember that number for later, 28. I also need to reposition the Mario sprite because it's currently centered, but I want it to be positioned standing on the floor of a single tile square. I press Ctrl-A to select the costume, and then drag to reveal the center point of the costume editor. I want Mario's feet to be positioned 8 pixels, and one more for the outline, below. Also, by holding Shift whilst dragging, the costume snaps to the horizontal or vertical position, keeping things aligned. Nice. Next, we need to map an editor key to the Mario spawn costume tile. Click into the editor sprite, and we'll make the tile key map list visible. Mario is costume 28, so at row item 28 of the list, we'll enter a key mapping of 4. Remember to click out to another row to make sure it saves that change. And it's testing time. I'll enter the level editor and press 4 until I see Mario appear. Cool. Then I can place him where I want the player to spawn. Okay, so I can see one potential issue. I can place more than one Mario. This will cause us problems, so let's stop that from being possible. So still in the editor sprite, find the When I Receive Move Player script and scroll down to the bottom. Before we replace the tile on the screen, add an if check whether brush equals 28. That's the Mario costume, remember? Make a new variable named foundIndex for this sprite only. Then set it to item hash of brush in tile grid. If another tile exists in our level of the same type as brush, which in this case is the Mario costume, then this will find it. Lastly, we replace item foundIndex of tile grid with 2, the empty tile. You should rightly ask here what happens if there isn't another Mario on the level. Well, in that case, foundIndex will be set to 0, and happily replacing item 0 of a list does nothing at all. So we are safe to leave the script like it is without having to worry. Shall we test again? Now, when I place a new Mario, the previous one disappears. That's neat. And so, all that's left is to actually get Mario to spawn at this location. Switch back to the Mario sprite. Here, in the When Green Flag Clicked script, when the game starts, we do the initial setup which loads the level, and then we reset the player. This is the first player spawn. Create a new broadcast and wait event named level start game loop respawn. That's a long one. We can then bring in an event receiver for this event and move the reset player and game loop blocks down into there. Okay, we'll make use of this more in a moment. In the meantime, bring in a When I Receive block and we'll make use of the existing level done loading event. This is called just after the level is loaded and before the game loop starts. So, it's a great place to process the spawn point. We'll need a new variable named spawn index for this sprite only, and set it to item hash of 28 in tile grid. That is the index of the Mario spawn point in the tile grid. Okay, so now that we've found the spawn point, if editor is less than 1, that is, if not in editor mode, then we replace item spawn index of tile grid with 2 to ensure the spawn point is no longer shown in the game. We can give this a quick test. Notice right away that the spawn index has been set, so the spawn point has been identified. Also note that Mario's tile at spawn point is only visible when we are in the level editor. So now, to get the spawn point to work, find the define reset player script, and we'll check with an if-else whether the spawn point is greater than 0. A value greater than 0 indicates that there is indeed a spawn point. I'm going to duplicate the set x and y blocks into each side of the if, and also below the if too. That's right, 3 pairs. So, this top pair is the most interesting. We want to change the spawn tile index into an x and y position on the level. We haven't done this translation before, having only gone from the xy position to an index. Luckily, it's not too complex. Start by setting x to the floor of, and then drop in a divide block. On the left side of the divide, we have spawn index, subtract 1, and on the right, we divide by grid height. This will leave x set to the grid column of the spawn index. To find the grid row, set y to spawn index, subtract 1, all modded by grid height. Okay, so because we are now working in grid tile positions, we can change the else condition below to default to spawn at tile 3 by 3, rather than pixel 100 by 100. This only happens when there's no spawn point set. And then finally, under the if-else, we convert back from grid location to world location by multiplying each of x and y by 32, and then adding an offset. The x is offset by half a tile to the centre of Mario. The y is offset by height, so that he is standing firmly on the floor. Now, while we are here in the reset player script, let's just tidy up a few things. We'll make sure to reset the camera back to the player's spawn point by setting camera X to X and camera Y to Y. And also, we'll importantly remember to set speed X and speed Y to 0. We should have done that from the beginning. Lastly, pop in a point in direction 90, so that we are facing the right way. And we'll place it just before the move camera block. Cool, we can test this. Spawn is working. Well, I certainly appear to have spawned in the right place, and if I move away and click the green flag, then I spawn straight back up here. Yay! So, how about if I enter the level editor and place the spawn point over here instead? Press the green flag, and ping! I am now spawning in the new location. Okay, so is there anything left for us to do? Well, just one thing. When we use the level editor to switch levels, we are not taken to the spawn point. The same applies to creating new levels. Luckily, this is quite easy to add, as we already have everything we need. Click on the level editor sprite and find the when L key press script. At the bottom here, we just switch the broadcast to use the new level, start game loop, respawn event. Remember I said we'd make use of this again? We do the same in the when R key pressed script below this too, changing to broadcast and respawn event. There's just one more script to update. If you can find the when 0 key pressed, we need to add a broadcast and wait to level done loading just before starting the game loop. This ensures we pick up the spawn point when exiting the level editor. And that is it, we are done running the project, and I can test entering the level editor and pressing the L to switch levels. If I say I want to switch to level 1, yes, that's the one I'm on right now, then the level reloads, and look, I am scrolled over to the spawn location as intended. Cool. Now to level 2. No spawn point was set yet, so I appear at tile 3 by 3. let me set a new spawn point on this level too. Now, exiting the level editor keeps me at the same position, but using the level switching key for level 2 spawns me up here at the spawn point. Yay! And back to level 1? Yep, that is amazing. I'm really pleased that we're finally getting these much requested features into our game. I've been honoured to see quite a few projects being built by Scratchers following along with this tutorial series, and they are looking so good. I hope perhaps we might be able to see some of them together later on when they get shared. That would be so cool. Now, what should we look at next episode? Feel free as always to drop me your suggestions under the video. But I've already been asked a lot for either off-screen enemies, power-ups, sloping tiles or moving platforms. Of course, I can probably only fit one of these in at a time, so yeah, let me know what you think in the comments below. If you've enjoyed this tutorial, then please smash the like button and don't forget to subscribe to this channel to avoid missing my next exciting video. Until then, thanks for watching and scratch on, guys.